Okay, so number one, a parabola has an x-intercept, or one of its x-intercepts at x equals 2. And the axis of symmetry is x equals 4. Which of the following represents the other x-intercept? Yes. Yes. How'd you get that? Okay. So remember, you could have done this without Desmos, all right? But what's a way? So that's one way you can do it if you put it in Desmos and you counted how far away it is from the axis of symmetry. But what's the other way?
You take how many is from the axis of symmetry and then you add 1.
Yeah, you could find the distance for between 4 and -2, and that's 6. So then you just take 4, add 6 to it, because obviously -2 is when you subtract 6. So that would give you 10. Because remember, axis of symmetry, what's always true about every point on a quadratic function except for the vertex? They have a symmetrical buddy. Yeah. Yes, Colin.
When you draw it on the graph, so if you put x one intercept of -2, and then the axis of symmetry at 4, it's like x equals 4. Then it's 6 away, and so the point that yields that would be 6 away from 4.
Yeah, so that's why it's x equals 10. Because -2 is 6 away from 4, but in the opposite direction. So if you do 4 minus 6, that's where you get -2. So 6 in this case is just the distance. Does that make a bit more sense?
Yeah, for some reason I keep getting x equals 11 when I count 6 away.
Make sure don't count the 4. All right, now this next one, you should definitely know how to do this by hand. So first off, all right, what form is this function given in? Standard. What's definitely something I can pull from the standard form? The y-intercepts. So what is my y-intercept? -8. So that'll be down. That'll be right here. Now, how can I find the axis of symmetry in vertex without having convert to vertex form? -b/2a. Good. So if I do -2 over 2 times 1, -1 is my x value. So that means my axis of symmetry is at -1. How do I find the y value of the vertex? Plug it in for x. So if I have -1 squared plus 2 times -1 minus 8, that'll be 1 minus 2 minus 8. -2 minus 8 is -10. So 1 minus 10, that's -9. So my vertex would be right here. Now, since we have one of the points, we can find symmetrical buddy on the other side. Now, last thing I want to find is the x-intercepts. How can I find that? You could put it into factor form, all right? Or you could do the pattern to find them. So remember, it's all based off of your a value. So if your a value is 1, if you go out 1, you do 1 squared. So the pattern, if for x, you go out 1, your y would be 1 squared because your a value is 1. So if you go out 2, your y would be 2 squared. So if I go out 2 from the vertex, how much up do I go? 4. So 1, 2, 3, 4. Find its symmetrical buddy. If I go out 3, how many am I rising? 9. So there's 4, 5, 6, 7, 8, 9. And then I find its symmetrical buddy. I know we just got the zeros, but let's go ahead and get the one more. So if I go out 4, how many do I go up? 16. So that's 9, 10, 11, 12, 13, 14, 15, 16. So your graph's supposed to look like this. Now it's saying our x-intercepts are at what? -4 and 2. Now let's double check by factoring that. So what are 2 factors in -8 that I'll add it to? 4 and -2. So x plus 4 times x minus 2. And remember, we just solve for x to get our x-intercepts. X would be -4 and 2. Now, why is all this important? Because it helps us answer the next questions. So if I ever ask you to graph one on your own, you always need to find the x-intercepts, the y-intercept, the vertex, and the axis of symmetry. Now, key features. Over what interval is f decreasing? So what does that mean? What's an interval of decrease? What does it look like? It's when your pencil's going down. So if you start from left to right, it's if you drag your pencil along this graph, it's when it's going down. So what direction is my pencil going right now? Down. But once I hit the vertex, what happens? It starts going up. So this over here is my interval of decrease. Now, for intervals of decrease and increase, do we use x or y values in the interval? X. All right, because we're looking for where the y values are decreasing. So we got to know what x values it's over. All right. So basically the only interval that you will ever use a y value in is range. Everything else is x values. So what is the lowest x value of which we start decreasing? Nope.
Like
-infinity. So if you look, since the arrow's all the way up here and we're on the left side, that means the lowest x value we start at is -infinity. Where does it stop? At -1. Now, do I put a parenthesis or a bracket for -1? Parenthesis. And the reason is that the vertex is kind of gray area. It's neither increasing nor decreasing. You could also write this as x has to be less than -1. That's the other way you could write it. Because remember, I don't care which way you write it as long as you understand what it means. Next, they asked, find the interval where f of x is less than 0. So what does it mean f of x is less than 0? Not when the x values are less than 0. When the y values are less than 0. F of x is another name for y. So we're looking for where our y values are less than 0. So in reference to the x-axis, right, because the x-axis is kind of the boundary because that is 0 for y. Where would the y values being less than 0 be located? It's located below the x-axis. That's what I'm getting at. So everything down here is your negative interval. That's when f of x is less than 0. Now, what are our two boundaries? The x-intercepts are your boundaries. So where does it start going negative? At -4. All right, because we start with x values only. When does it end? So when does it change to positive? 2. What do I put around these? Parentheses, because what's not here? It's not less than or equal to. If this was an equal to, then you put brackets. But since it's not, you keep it as parentheses. Another way you could write it, you could have written it as a compound fraction. You could have said -4 is less than x, which is less than 2. Either way. Probably not. You may have some tomorrow though. Lastly, the range. So remember, range is your only y value. What is typically the range based around though? We know it's y's, but what point specifically kind of gives us an idea? The vertex. So it's basically based on whether the vertex is a max or a min. What's the vertex in this case? It's a min. So does that mean the y value of my vertex is going to be my lowest y or my highest y? Lowest. So how would I write this? Good. Basically, -9 is your lowest y value, and then the rest of the graph is above that. We use a bracket if it's exact. So since the vertex is defined at -9, we can actually say that. Yeah, you can use that too. You can do y is greater than or equal to -9. That works as well. I don't care which way you write it as long as you understand. That's the way what it's talking about. All right. Next. These two you could have used Desmos for. You could do that too, but teach their own. So you have an initial velocity of 86 meters per second, initial height of 6.2 meters, and this is the function that gives the height of that object since it's fired. So if it hits its peak height at t equals 8.775 seconds, what is the closest to its greatest height? So one strategy that you could have done is you could have plugged that in for t. So I have -4.9 times 8.775 all squared plus 86 times 8.775 plus 6.2. The other way you could have done it if you used Desmos is you could have graphed both of these functions. Just replace the h and the t with x and y. All right, so it would be x equals 8.775, and then find the point of intersection. So what would the y value be closest to? 384. Good. So two different methods. Doesn't really matter which one you use. Last one. So we have a 25-story building. The students found the height in feet, h as a ball above the ground as a function of the number of seconds t since it was dropped, and it gives that function. So from what height was the ball dropped at? 300. How do you know? It's the constant, which means it's the what? Y-intercept. So 300 feet. That and it says feet. But yes, you can, because technically 16t squared is the metric for gravity in feet. All right. Yeah. All right. Then to the nearest tenth of a second, determine the time at which the ball hits the ground. So that one, you're looking for the what? The positive x-intercept. Good. So what is that to the nearest? Yes, sir. 2.5. Good. 2.5 what? Seconds. We're talking about time.
Yeah, I got 4.3.
I didn't check, y'all. I trust y'all. You're honors kids. I should be able to trust you.
Well, yeah, for sure. I can't tell you.
Double check and make sure you. Yeah, it is 4.3. All right, so shh. All right, so that was just to get your brain thinking back about quadratic functions. All right, so today we're actually going to be talking about quadratic inequalities, all right, and how to solve them. So, very similar to how you would solve linear inequalities, which you guys learned back in Math 1. So, first off, so far we have learned how to solve quadratic equations, which we have. Yeah. Now we're going to look at solving those inequalities. So, we're finding all values of the variable or variables that make the inequality true. So, the difference between equations and inequalities. Equations, there's usually one or two numbers where it's exactly going to be that value. So, like, for example, when we solve quadratics, we typically have it set equal to 0. There's only between one or two values when you plug that in for x, that will give you 0 when you plug and chug it. Inequalities, it's a span of numbers that make the statement true. So, for example, whether it's greater than 0. All right, there'll be a span of numbers that you can plug in for x that will make the value greater than 0. All right. So first things first, we're going to figure out if the value that they give us makes the inequality true. So they told us that x squared minus 3x minus 10 is greater than 0, and we're going to find when x is equal to 4. So we're going to plug in 4 in for x. So I have 4 squared minus 3 times 4 minus 10, and I want it to be greater than 0. That's the end goal when we evaluate. What's 4 squared? What's negative 3 times 4? Minus 10. 16 minus 12? 4 minus 10. What's 4 minus 10? Negative 6. Is it true that negative 6 is greater than 0? No, so that does not make it true. So no, it's not true. So x equals 4 would not be part of what we call the solution set if we solve that quadratic. All right, x equals 2. We're going to plug that into this function. So I have 2 times 2 squared plus 13 times 2 minus 7. And we want to be either greater than or equal to 0. What's 2 squared? Times 2? 8. 13 times 2? Minus 7. What's 8 plus 26? 34. Minus 7. What's 34 minus 7? 27. Is it true that 27 is greater than or equal to 0? Yes. So x equals 2 is in the solution set. So if we were to solve that quadratic inequality, x equals 2 would fall into whatever our answer would be. Last one, negative 3. So I have negative 3 squared minus negative 3 minus 12, and we're wanting it to be less than 0. What's negative 3 squared? Negative times a negative? Minus 12. So this is 12 minus 12. So we have 0 is less than 0. Is that true? No. So because it's equal to 0 and we don't have an equal to symbol under it, that doesn't make it true. So it's not in the solution set. So be really careful about those inequalities. Now, how to actually find these solution sets. It's basically similar to how you would solve a quadratic. And then you just kind of have to logic your way through the inequality part. All right. So the solution set of inequalities like these cannot be written in roster form. So in other words, there's not going to be like a total list of solutions. So we know that only 1, 2, 3, or 4 will work. Can't do that. Only way we can write out for an inequality is using either inequality form or interval form, because there can be an infinite number of solutions to that inequality as long as it's within a certain range. All right.
Is there not infinite?
Hmm?
Like, it can be like a finite number, if it's like in between.
If it's in between, well, if you think about it, you're also including decimals, fractions, every little tiny decimal that's in between those two numbers. So technically it's still infinite. Because decimal places, you can go down to like, the 10 billionth of a decimal place. All right, so first off, let's solve this algebraically first. So we're just going to solve this equation by itself. Now, what's always the first thing you want to check to see if you can solve for it? Factor it. All right, do you think that can be solved by factoring? Yeah, I can. Now, what's a way you can check if you don't know? Well, what's a way you can easily check to see if you can factor it or not without having to do all the work? Find the discriminant. So let's say I take b squared minus 4ac real quick. So if I can factor it, it's going to be what? A perfect square and positive. So I have 2 squared minus 4 times 1 times negative 3. So that'll be 4. Negative 4 times 1 is negative 4 times 3 is 12. And that's 16. That's a perfect square and it's positive, so it's factorable. So we can do big X. I mean, you could, but I'm just saying, like, you don't actually have to write it out. Like, that's just something that you can throw really quickly in your calculator if you didn't know it was factorable or not. So, A times C is negative 3. B is 2. Where are two values now multiplied negative 3, but added 2. Negative 1 and 3. Thus, my factors are what? X minus 1, X plus 3. And again, I can do that because the A value is 1. If not, that's when you want to use either T method or reverse box. And you can still use reverse box if you are unsure about that. It's fine. But I'm not spending time on the factoring side of it because you guys should already be able to do that. So, how do I solve? Set them both equal to 0, solve them separately. So x is equal to 1, x is equal to negative 3. So this is where my function is equal to 0. This is also going to be my barriers. All right. So in other words, this is what we call my barriers. So our inequality answers are going to be written in some form using when it's equal to 0. But we're looking for when x is, or when that equation is less than 0. All right, so we want our answer to be less than 0. So now we can see kind of what's going on. So we know that when it's at negative 3, it's 0. We know that when it's at 1, it's 0. All right. Now we need to find the other values. What's a very quick way that I can find it without having to just plug and chug? Using the calculator, but you can generate a table. So if I pull up my calculator, who remembers how to generate a table in your TI?
Second and then graph.
Y equals, clear out a graph that's there, type it in, x squared plus 2x minus 3. Then you just hit second and then the graph key. And so you can just copy down all the numbers that's there. So it looks like it's 12, 5, 0, negative 3, negative 4, and then it repeats. So 12, 5, 0, negative 3, negative 4, negative 3, 0, 5, 12. No, it's going down. It should be negative 4. So just for funsies, where's my vertex?
Negative
1, negative 4. Now, that's not important in this case. I just want to see if you'd be able to recognize where it is. So these are my solutions. So this is when it's equal to 0. All right. Now, why are the zeros in this case not part of the solution set? Right, it says less than 0, not less than or equal to 0. So it's because it is less than, not less than or equal to. Because if it said equal to, then heck yeah, the -3 and the 1 would be part of my solution sets. All right. Now, here's my question. What numbers would be in my solution set from this table? So I want values that are less than 0. So what values would work? So here's my question. Am I looking for x values that are less than 0 or y values that are less than 0? Y values. So where are my y values less than 0? There you go. So this is where my y values are less than 0. So here was my question. Is it between those two solutions or is it on the other side of each? It's between them. So how do you think I would write my solution in terms of x? -3 is less than, not less than or equal to, less than x, 1. Good. So you can write it as a, who remembers what this is called? You learned it back in math 1. Well, it's an inequality, but it's a specific type of inequality. What's it called? Starts with a C. Nope. Compound. So this is called a compound inequality, which you can use if your solution is between two numbers. Only when it's between two numbers. Now, if it was on either side of the numbers, you can't use that. If I wrote this using interval notation, what would it look like? And we use parentheses y. It's not those numbers equal to it. All right. So, the key to solving an algebraic inequality is to first find the zeros. So in other words, you need to first solve the equation. So in other words, you said equal to 0 and solve by any of the methods that we have used. I don't really care at this point. So you can use quadratics, you can use factoring, whatever you're most comfortable with. Then you test points between and outside of the zeros. All right. So in other words, you would do something similar to like this table. And you really only need to test 3 different numbers. So let's say that if I was testing this, I would test a number on the outside of -3, so less than -3. I would test a number in between 1 and 3, -3, sorry. And I would test a number greater than 1. And basically, what you're going to do is plug those numbers back into your original function and see if you get less than 0 as their numbers. And that'll tell you where your solution set lies. Yep. Inequalities are a pain. So let's do some more. All right. Now, I can tell you right now, pretty much all these are going to be factorable. All right. So we don't really need to check to see if they're factorable because for these, they're all going to be factorable. So how would I factor this one? So -36 on top, -5 on the bottom. So our two values that multiply to -36 add to -5. -9, +4. So this would be x plus 4 equal and x minus 9. And we're solving when it's equal to 0. And again, the only reason I can go straight to my bubbles is because the a value is 1. If the a value is not 1, do a reverse box or T method. So what's x going to be equal to? -4, +9. So that's what x is equal to. Now I got to test the numbers. So here's kind of how I do it. So I put -4 and 9. All right. So you're testing 3 different numbers. So in other words, if you made a number line, all right, you'll do one number less than -4. I recommend an easy number. One number between -4 and 9, and one number greater than 9. And you're going to test them. So let's do a number less than -4. So what's a number less than -4? -5. So -6 works too. It doesn't matter. But -5 is the closest one. So -5 squared is 25 plus 25, so that's 50, minus 36. Is that going to give me a value less than 0? No. All right. So what's 50 minus 36, just so we have the number? 14. All right. We know that these are my zeros, so we don't have to worry about them. What about in between? Pick an easy number in between. I would do 0. I would 100% do 0. If 0 falls in between them, you better pick 0. Because what's the answer? -36 is whatever the C value is. And then we'll pick a 10. So, yeah, still 14. So, if I want them to be less than or equal to 0, do I want numbers on either side of -4 and 9, or do I want between? In between. So this is where our solution set will be, in between. Now, here's the other question. Do I include the -4 and the 9 in my set?
Yes.
Yes. Why? It has that equal to. So I always recommend writing it as, you can write in either form. Let's start with interval notation. So how would I write it in interval notation if it's between? X, which is less than or equal to 9. So since it has that equal to, make sure you also throw the equal to's in your answer. How would I write in interval notation? Bracket -4, 9, bracket. Again, I don't really care which way you write your answer in. It's whichever one you understand the most. Any questions on that one? So basically, solving inequalities, it's really easy. It's just solving a quadratic equation with just the extra step of just taking like 2 seconds to plug and chug and figure out where the solution set will be. Any questions on that? Huh? Yeah. All right, let's try B. So B, I got to factor it first. So big X. What goes on top? -60x squared. What goes on the bottom? 28x. So this one's one you probably have to use either T or reverse box for. So what are 2 factors of -60 that will add to 28?
2 and 30.
Yeah,
30 and
yeah, yeah,
-2.
yeah. 30 and -2. Good. So which one do you want me to do? Do you want me to do T or reverse? T. Okay. I heard T first. That's what I'm going to do. So I have x squared plus 30x minus 2x minus 12. What's the GCF of the first group? 5x. What am I left with? X plus 6. Next group, what do I have to do first before I take a GCF? Bring down the negative. What's the GCF? 2. So what am I left with? X plus 6, because we took out -2. So what are my 2 factors? Oops. X plus 6, 5x minus 2. All right. This should be second nature to you guys by now. All right. So if I solve for x, I have x plus 6 is equal to 0. 5x minus 2 is equal to 0. So x is equal to negative 6. What would this one be if you solve that two-step? 2/5. So that's my solution set. Now I need to check to see where my inequality will be. So I have negative 6 and 2/5. These are where they're both 0. So I would do, let's say, negative 7. Doesn't really matter. You have calculators. So negative, yes. Write your name on the word. So I have negative 7. Then I can use 0. And then 2/5 is a number greater than 2/5 is 1. So we can just use 1. And again, it doesn't matter what numbers you pick as long as they fall less than negative 6, in between the two, greater than 2/5. You could pick any number, but I just pick small ones that make sense. So if I plug in negative 7, what would you get? Just plug it into your calculator. You get 37. So if I plug into my calculator negative 7, so I have, second clear. Look up here, guys. Come on. So I have 5 times negative 7 squared. Crap. What was it? Plus 20 times 28. Guys, I don't have it in front of me. Give me a hand here. Times negative 7. And then minus 12. So yes, it is 37. Where is it at 0? That should be easy. Negative 12. 1. So that's 5 plus 28 minus 12. That's 5 plus 28 minus 12. Let's see, that's 33 minus 12, that's 21. So we're looking for numbers that are greater than 0. So which would be my solution sets? 1. What else? Negative 7. 2/5 is not my solution set. Why? No, not because it's a fraction. It's because it's not equal to 0. Right here, it says only greater than. We don't want equal to. Now, this is a little bit different. So, since it's on either side of our line, all right? Yeah. So, guys, what in the wide world? Okay. So, if I were to draw this on a number line over here, so this was from letter A. I had negative 4 and 9. Shh. Did I have open or closed circles here? Closed because it was equal to, which means it's defined there. Open means it's undefined. And would I shade on either side of them or between? In between. That's where my solution set was. So, let's say I drew a number line for this one. I have negative 6 and 2/5, but I have open or closed circles on them. Open. Now, based off of where my solution set is, am I going to shade in between or on either side? Either side. So now let's write an inequality that represents that. So, x and 6. What do I need? Or negative 6, sorry. What do I need to put between that? Am I talking about x values that are less than 6 or greater than 6? Less than. It's to the left of -6, which on a number line, that means it's smaller than it. What about for 2/5? It's shaded to the right of 2/5, so it's greater than. Now, we cannot make this into a compound inequality because they're going in opposite directions. They're not between. There just isn't. So what we do is we separate by a single word, that being or. So why we can't, that brings up the discussion of or and. All right. Or and are two very different things. Specifically when you get to probability. Whereas and means both. Or means at least one. So and means that both has to be true, or means at least one has to be true. So what it's saying is that for this one, x has to be both greater than or equal to -4, and x has to be less than or equal to 9 in order for this inequality to be true. All right, that's an and. So this is technically an and statement, meaning both conditions have to be met. Whereas this is condition 1 and this is condition 2. So -4 has to be less than or equal to x. So in other words, if you flip that, x has to be greater than or equal to -4. And x has to be less than or equal to 9. That's how we find a value that fits our solution set for that one. This one, is it possible for a number to be in both less than -6 and greater than 2/5 at the same time? No. That's why we use or. Because as long as it fits one of the conditions, it's true. All right. So as long as the number that we pick for x is either less than -6 or greater than 2/5, it will fit or make our inequality true. Does that make sense? The difference? All right. So if I wrote this as as interval notation, though, what do you think it would look like?
Is it like two of them next to each other?
Yep. So you're going to have two different intervals separated by a union symbol. So let's start with the lowest one. So if x values are less than -6, that means my lowest x value can be what? -infinity. So we go from -infinity to -6. Close it with a parenthesis because it's not equal to. Union, because it takes a break and then picks back up at 2/5. Where does it end? Infinity.
But we never you were required to put in one method.
You may see it like that. So you may not be required to put it in that. You just may see it. So you need to understand what that means. So again, I don't care which way you write it, as long as you understand that's what it means. All right. I want you to try C and D on your own. So, in other words, so do you want me to do one of them and then have you try the other one? I'll do C. All right, so let's do C real quick together. So if we don't have one side equal to 0, what do we have to do? Move it over. So I'm going to subtract the 10x over. I'm going to add the 8 over. This one's actually pretty easy because I have 2x squared minus 14x. What happens to the 8s? Cancel. Less than or equal to 0. How do I factor that? 2 and x. Surprisingly, this was the problem that y'all missed the most on the test. You'll see. I mean, it doesn't matter. It really doesn't matter. Guys, not gonna lie, my standard kids did better on it than you. So
They're freaking geniuses.
the first 5 questions, which were the exact same on both tests, my standard kids did better.
Bro, they're just
Yeah,
smart.
this there was a bonus question because I felt cheated. I went to the other test and I was looking for that bonus question and I couldn't find it.
Well, that doesn't mean you have one. You're not always gonna have a bonus question.
So sad.
All right, so 2x is equal to 0, x minus 7 is equal to 0. So what do my x have to be equal to? 0 and 7. All right, so now we're going to find numbers around them. So I have 0, 7. What 2 numbers do you want me to pick? So I'll pick 1, -1, and I just do 8. Now, I would plug these numbers into this function because that's way easier. All right. So I would do, what's -1 squared? Times 2? All right, what's -1 times 14?
-14.
Or positive 14, because I forgot to say negative. So 2 plus 14? 16. If I plug 1 in, I have 2 minus 14, which is what? -12. If I plug 8 in, I have 64 times 2, which is 128, minus 14 times 8. So that is, I don't even want to figure that one out. 112. So 128 minus 112, which is?
16.
It's 16. And remember, these are both zeros. So we're looking for when it's greater than or equal to 0. So which is in my solution set? The outsides. Now, are the zeros in it? Yes, they are also included because of the equal to. So if I were to draw this on a number line, sometimes, well, you will be asked to draw it on a number line, but it also helps you figure out how to write your answer. All right. So I have -1. Nope, sorry. I have 0 and 7. Am I going to do open or close circles on these guys? Close, because it's equal to. So do I want values less than 0 or greater than 0? Less than 0. Because -1 is less than 0. And then I also want greater than 7 because 8's greater than 7. So is this going to, can I write this as a compound inequality or do I have to write an or statement? Or statement. So how would I write it? X is less than or equal to 0 and x is greater than or equal to 0. Don't forget the equal to. Because now you're saying, so write it backwards. So if you do it like that, you're saying x has to be greater than 0 and x has to be less than 7.
Because they have to point backwards. They have to point away from that.
But you still can't write it as a compound. You have to use a or.
I just wonder.
Yeah. So how do I write that in interval notation? That is supposed to be a 7, by the way. Does 0 have a bracket or parenthesis? Bracket. Union symbol, which is just an uppercase U, by the way. Don't forget the union symbol. That is part of how you have to write it if you write an interval. Where I start back up. Union is just a fancy way of saying or.
We say or instead of it.
No, you still have to put the union symbol because that's just how it's written.
And then you put 7 and positive.
So union you'll use more with probability, and you'll also see it again. It's used exclusively with really probability and intervals.
Math.
Well, there's union and then there's intersection. Intersection's and. It's an upside down U. All right. Try D on your own.
Hey, fish would be nice.
That's okay.
You need to get better with
I'm a great man.
This requires 20 plus hours of training.
We're still teaching.
So start by solving the inequality. Start by solving the equation first. Again, you don't necessarily have to solve by factoring if you don't want to. If you have another method that you like, I don't care. As long as you do it correctly.
No matter what, but you put it all on one side. Do not get this, and you get different squares. Because 25 is the first.
Remember, before you even start solving, you gotta get one side equal to 0.
And then working with negative or positive, I will do the same thing. So you don't get there. You know that's going to be negative zero, so that means the house is
You should have two answers for this one. You solved it by two answers for yeah, with the plus minus in front of it. Also, how to stay on the test. Actually, I did pretty good on that.
What'd you get, bro?
17. It's the highest I'll call you.
That's so good. Don't even. I did
so like come over and whisper to you.
92. See? You make me seem
What did you?
Yeah, I got an 86 too.
Yeah, you're right.
Bro, that was like hard.
Okay.
Dude, I did terrible on my job.
I have second period planning if your second period teacher will let you.
Miss Hell is not about to let me come.
Before we get my
Or are you gonna be your person?
Allison, what do you
So
have?
we're just doing asynchronous on Friday. We're basically just sitting in your program all day. So if you want, I can write you notes or my meeting tomorrow.
It's a field.
Because I have a sophomore class, so like that means that you guys So in the morning, I'll write you notes and ask your program teacher. You're basically just staying in your room all day.
No, like what?
Move my podium back.
Okay, I didn't move it over here.
I told you, he's hoping me.
I'm kidding. I was messing with you.
Riley's Miss Worth.
Again, not your dog.
Miss Worth.
Guys, I should not have to keep telling you
Oh, sorry.
to not touch each other. What are you doing? All right. Let's go over this. All right. So first step. Hush. What's my first step?
Bring the 14 and 19 over.
Bring the 14 and 19 over to one side. That goes away. X squared. These cancel. Negative 25 is less than 0. That is definitely a difference of squares. So you can factor like x plus 5, x minus 5. Yep. X equals negative 5 and positive 5. Now, if I make my table, all right, here is negative 5, 5. Let me draw my line. What number did you pick to be less than negative 5? What did you pick to be between? What did you pick to be greater? So what'd you get when you plugged in negative 6? 11. That's 0. What'd you get when you plugged in 0? Negative 25. 0. What'd you get when you plugged in 6? 11. So we're looking for when it's less than 0. So which is in my solution? The middle. Because negative 25 is less than 0. So in other words, is it going to be between these two numbers or on either side of them? Between. So if I do this on a number line, I have negative 5 and 5. What type of circles do I draw? Open, because they're not equal to. And I want to shade in between. So how do I write my final answer in inequality notation? Less than. Good. How do I write that in interval notation? Not bracket. Because it's not equal to. Good. All right. So basically, based off of what we've looked at so far, what sign typically gives you a between? Greater than 0 or less than 0? Less than 0 typically gives you a between. Whereas greater than typically gives you an or, so on either side. More often than not, unless you, the only time it's not is if you end up having to divide a negative over and, the signs flip, but that won't.
I don't plan on it.
So, if I looked at this next problem, without even looking at it, we can kind of process eliminate this without solving. So, based off of what's going on here, first off, should it be equal to 0 or not? So should our inequality have an equal to under it or not? Yes, because what's true right here? They're closed circles, so that eliminates 1 and 2. Now, it's between the two numbers. So should that typically be a greater than or a less than? Less than, so that's 4. We don't even have to solve that. Same thing here. So, now this one is kind of a little funky, so we're going to actually solve this. And the main reason is right here. Your A value is negative. Because what I tell you have to do if your A value is negative and you're solving? You either got to move everything to the other side or you got to divide by negative. I'm just going to move everything to the other side because that makes life easier. You're about to see it. So I'm going to add all of this to the other side. So that all cancels out. So I have 0 is greater than or equal to 2x squared minus 7x plus 3. So if I switch it, that means I have 2x squared minus 7x plus 3 has to be less than 0. Because I got to keep the direction of which it's pointed consistent. So this is an example of when it flips the sign. All right, so if your A value is negative, that's how you can tell if you have to flip the sign. If your A value is negative, you have to flip the sign. All right. So let's take a minute and solve this. All right. So automatically, what can we eliminate? Just from our answer choices, so we don't even have to worry about it. If it's less than now, 3 and 4 can go bye-bye. Because it's not going to be a greater than anymore. It's going to be a less than. So if your A value is negative, you're going to flip the inequality. So that's why it becomes less than here. Now, that means if I factor this, so this would be 6, -7, two values of 6 add to -7. Y'all, come on. Two values of 6 that add to -7. -6, -1. So for time's sake, I'm just going to tell you what the factors are. So 2x minus 1, x minus 3 is equal to 0. So x is... Guys, keep fooling around. I'll just double the amount of work that I want you guys to do over spring break.
Don't be like this out.
This house, like, this house.
You're
like the only
If you-
good teacher I am.
2 times
If
0
you
is
don't
still
want to work over spring break, don't piss me off.
You're gonna have homework right
Richie, gotta give her a fist bump.
now. Tell me to give you a fist.
So, since I have 1/2 and 3, that automatically can give me my answer without even have to figure out numbers in between them. What's my answer? 1. So guys, that's the example of when your inequality flips. If your A value is negative, your inequality is going to end up flipping. All right. Any questions on that? Huh? Nope. Like literally if you graphed it, because so like if you look at it from a graph standpoint, since it's a negative A value, it would look like this. So let's say our zeros were right here. All right. Where are the y's greater than 0? So on this graph, in between them, because it's above the x-axis here. So that's why. Whereas if it was looking like this, say our y-intercepts were here, it would be greater than 0 here and here, because that's where it's above the x-axis. So that's just how you can look at it from a graph perspective. You're looking at whether it's above or below the x-axis. If you want it to be greater than 0, that means you want it above the x-axis. Less than 0, below the x-axis. So our graph, this graph, if we didn't do anything, would look like this. Any questions? Okay, so your homework for tonight.
Richard, stop wasting time.
Don't even blame me. Don't even.
Oh, you're Richard, just stop talking out. It's all your fault.
You want more work?
I'm gonna give you a homework.
Miss Murphy hates you because of all this stuff that you're
Close
doing.
your packet real quick. I just have to get the base.
Someone put something inappropriate on our work.
Wait, so what's our homework? Your homework is pages 8 and 9. Yeah. I'm checking it tomorrow. 8 and 9.
What is Friday's work gonna be? Because I can't. What's it gonna be?
Depends on if we get through this or not. So it's either going to be.
I'm gonna be here tomorrow. So
That's what I'm saying. It depends how far we get tomorrow. We'll have to decide. Just check campus.
it's gonna be on. Okay, that's good. Just to make sure I can.
Because you're not even technically you wouldn't even see me on Friday anyway.
Yeah.
You're gonna be here in Pearl all day, so everything's gonna be posted on campus. So just check that. It's probably just gonna be a watch the video, get the notes. Depending on how far we get. If we get through like all of what I want to get through tomorrow, then we're good.
Unlikely, but
Well, not with these maroons.
Whoa, whoa, you're weird that.
I said maroons.
I didn't hear what you said, so I'm not taking your word.
You just gave Richard like 20 extra video issues.
That's probably why she had second birth. Came to class.
I mean, you're gonna get a